Namaste to everyone. I welcome you all in my YouTube video channel. Today I will discuss the Laplace transformation, lecture number 7, in which the inverse Laplace transform will be discussed. Now we define inverse Laplace transformation. If small fp be the Laplace transformation of the function capital Ft, and we write then Laplace transformation of capital Ft equal to small fp, then capital Ft is called the inverse Laplace transformation of the function small fp, and it is written as capital Ft equal to L inverse small fp. L inverse is called the inverse Laplace transformation operator. Now we shall show that inverse Laplace transformation is a linear transformation. That is linear property of the inverse Laplace transformation. Statement: let f1p and f2p be Laplace transformation of functions capital F1t and capital F2t respectively, and C1, C2 be two constants. Then L inverse C1 F1p plus C2 F2p equal to C1 L inverse F1p plus C2 L inverse F2p. We shall prove this. Let L F1t equal to F1p implies that L inverse F1p equal to F1t, and L F2t equal to F2p implies that L inverse F2p equal to capital F2t. Since L C1, here we take the Laplace transformation of inverse Laplace transformation of C1 F1p plus C2 F2p equal to C1 L inverse F1p plus C2 L inverse F2p. Since we know that C1 F1t plus C2 F2t equal to, since Laplace transformation is a linear transformation, so we may write C1 L F1t plus C2 L F2t. This is C1 L F1t equal to F1p, C2 L F2t equal to F2p, small f2p, implies that L inverse C1 F1p plus C2 F2p equal to C1 capital F1t plus C2 capital F2t. we use L inverse of this equal to C1 F1t plus C2 F2t. We may write right side C1 F1t is L inverse F1p. L inverse F1p plus C2 F2t equal to L inverse F2p. L inverse small f2p, that is L inverse C1 small f1p plus C2 f2p equal to C1 L inverse f1p plus C2 L inverse f2p. This is the linear transformation property of inverse Laplace transformation. Now we shall derive some formula of inverse Laplace transformation. As number 1, as you know that L1 Laplace transformation of 1 is 1 by p, implies that L inverse 1 by p equal to 1. This is the formula for L inverse 1 by p equal to 1. Number 2, we know that L e to the power at equal to 1 by p minus a, implies that L inverse 1 by p minus a equal to e to the power at. Number 3, L cos at equal to p by p square plus a square, implies that L inverse p by p square plus a square equal to cos at. Number 4, L sin at equal to a by p square plus a square, implies that L inverse a by p square plus a square equal to sin at. Number 5, L hyperbolic cos hyperbolic at equal to p by p square minus a square, implies that L inverse p by p square minus a square equal to cos hyperbolic at. Number 6, L sin hyperbolic at equal to a by p square minus a square, implies that L inverse a by p square minus a square equal to sin hyperbolic at. Now L t to the power n equal to gamma function n plus 1 by p to the power n plus 1, implies that L inverse gamma function n plus 1 by p to the power n plus 1 equal to t to the power n. As we have seen that inverse Laplace transformation is a linear transformation, so we may write gamma n plus 1 outside L inverse 1 by p to the power n plus 1 equal to t to the power n, implies that L inverse 1 by p to the power n plus 1 equal to t to the power n by gamma function n plus 1. So if we write n in place of n plus 1, we will get L inverse 1 by p to the power n equal to, here n, then here n minus 1, here will be n. So t to the power n minus 1 by gamma n. This is the formula for L inverse 1 by p to the power n equal to t to the power n minus 1 by gamma n. Now we solve some problems based on formula of inverse Laplace transformation. Number 1. Since we know the formula L inverse 1 by p to the power n equal to t to the power n minus 1 by gamma function n. So here L inverse 1 by p to the power 4 equal to t to the power 4 minus 1 gamma 4 equal to t cube by factorial 3 equal to t cube by 6. Number 2. L inverse 1 by square root p equal to t to the power half minus 1 by gamma half equal to t to the power minus half by square root pi equal to 1 by square root pi square root t. Number 3. L inverse 1 by p to the power 7 by 2 equal to t to the power 7 by 2 minus 1 by gamma 7 by 2 equal to t to the power 5 by 2 by 5 by 2 into 3 by 2 into half into gamma half equal to 8 t to the power 5 by 2 by 15 gamma half is square root pi. Now we shall find a Laplace inverse Laplace transformation of p by p square plus 2 plus 6p by p square minus 16 plus 3 by p minus 3. And we know that inverse Laplace transformation is a linear transformation. So we may write this equal to L inverse P by P square plus 2 plus 6 L inverse P by P square minus 16 plus 3 L inverse 1 by P minus 3 equal to L inverse P by P square plus square root 2 square plus 6 L inverse P by P square minus 4 square plus 3 L inverse 1 by P minus 3 equal to, this is cos root 2t this is cos hyperbolic 4t, this is e to the power 3t. Now we solve the next problem. Here we know that inverse Laplace transformation is a linear transformation, so we may write this equal to L inverse 6 by 2p minus 3 minus L inverse 3 plus 4p by 9p square minus 16 plus L inverse 8 minus 6p by 16p square plus 9 equal to, we takes out 6 and 2, L inverse here 6, 1 by 2 common, p minus 3 by 2 minus L inverse 3 by 9p square minus 16 minus L inverse 4p by 9p square minus 16 plus L inverse 8 by 16p square plus 9 minus L inverse 6p by 16p square plus 9 equal to 2 outside, 2 L inverse 1 by p minus 3 by 2. Here we take L inverse, we take 3 outside, 3 also 9 at the same time, L inverse 1 by p square minus 16 by 9 here we take 4 outside, also 9 outside, 4 by 9 L inverse p by p square minus 16 by 9 plus L inverse. We take 8 outside and 16 outside. 8 and 16 L inverse 1 by P square plus 9 by 16 minus 6 outside and 16 outside L inverse P by P square plus 9 by 16, this equal to 6 by 2 3. Value of this is e to the power 3 by 2t L inverse 1 by P minus A is e to the power 80 minus 3 by 9 is 1 by 3. Here we need 4 by 3 L inverse 4 by 3 by P square minus 4 by 3 square. So we take outside 3 by 4 to adjust this 4 by 3 minus 4 by 9 L inverse P by P square minus 4 by 3 whole square plus 8 by 16 is half L inverse. We need here 3 by 4. So we write here 3 by 4 by P square plus 3 by 4 square. Then take outside 4 by 3 minus 3 2 are 6 and 8. Here we write 3 by 8 L inverse P by P square plus 3 by 4 whole square. So we get equal to 3 e to the power 3 by 2t minus 3 cancel 1 by 4 minus 1 by 4. This is cos a sine hyperbolic 4 by 3t this is 4 minus 4 by 9 cos hyperbolic 4 by 3t. This is 2 by 3. Here cancel 2 by 3. Here sine 3 by 4 t minus 3 by 8 cos 3 by 4 t. This is the required result. Now we solve a problem of inverse Laplace transformation. Here this is the given problem. Since inverse Laplace transformation is a linear transformation, so we may write separately of each part L inverse 5 by P square plus L inverse square root P minus 1 by P whole square minus L inverse 7 by 3p plus 2. Here we may take 5 outside. Here L inverse we a minus b whole square formula by p square. We take 7 and 3 outside, so remains 1 here. If we take 3 here common, then remain p plus 2 by 3. Here 5 L inverse 1 by p square is t to the power 2 minus 1 by gamma 2 plus L inverse p by p square minus 2 square root p by p square plus 1 by p square minus 7 by 3 L inverse p minus 2 by 3 means p plus 2 by 3. Here we get only t, gamma function of 2 is 1. We take separately this L inverse p by p square means 1 by p, 2 by square root p by p square, p to the power 3 by 2 plus 1 by p square, and 7 by 3 formula of this 1 by p minus a, L inverse is e to the power at. Here a is minus 2 by 3. So here we get 5t. Here we take separately L inverse 1 by p minus L inverse 2 outside 1 by p to the power 3 by 2 plus L inverse 1 by p square minus 7 by 3 e to the power minus 2 by 3t. Here 5t, L inverse 1 by p is 1 minus 2 L inverse 1 by p to the power n, t to the power n minus 1, n is 3 by 2 by gamma function 3 by 2. Here t to the power 2 minus 1 by gamma function 2 minus 7 by 3 e to the power minus 2 by 3t. Here we write 5t, here 1, here minus 2, here t to the power half, gamma function 3 by 2 is half, gamma half is square root 5, plus here t, gamma 2 is 1 by 1 minus 7 by 3 e to the power minus 2 by 3t. So we get 1 here 5t plus t 6t minus here half into this 4, here minus 7 by 3 e to the power minus 2 by 3t. This is the required result. Now we shall show that L inverse 1 by p cos 1 by p equal to 1 minus t square by factorial 2 square plus t to the power 4 by factorial 4 square minus t to the power 6 by factorial 6 square plus dot dot. Since we know that formula cos 1 by p equal to 1 minus 1 by p square by factorial 2 plus 1 by p factorial 4 by factorial 4 minus 1 by p factorial to the power 6 by factorial 6 plus dot dot, as cos x equal to 1 minus x square by factorial 2 plus x to the power 4 by factorial 4 minus x to the power 6 by factorial 6 plus dot dot dot. So we multiply both sides by 1 by p. Here 1 into 1 by p, 1 by p, 1 by p to the power 3, 1 by p to the power 5, 1 by p to the power 7. Now we apply L inverse. Since Laplace transformation is a linear transformation, so right side will be separately inverse Laplace transformation. So L inverse 1 by p, we may take outside 1 by factorial 2, L inverse 1 by pq, we may take out 1 by factorial 4, L inverse 1 by p to the power 5, and minus 1 by factorial 6, L inverse 1 by p to the power 7. L inverse 1 by p is 1, 1 by factorial 2, 1 by p to the power n equal to t to the power n minus 1 by gamma n, means here t to the power 3 minus 1 by gamma 3. Here also t to the power 5 minus 1 by gamma 5. Here also t to the power 7 minus 1 by gamma 7. Gamma 3 is factorial 2. Gamma 5 is factorial 4. Gamma 7 is factorial 6. So we get 1 minus t square by factorial 2 square plus t to the power 4 by factorial 4 square minus t to the power 6 by factorial 6 square plus dot dot. Now we solve another problem of inverse Laplace transformation. L inverse 1 by p sine 1 by p equal to t minus t cube by factorial 3 whole square plus t to the power 5 by factorial 5 square minus t to the power 7 by factorial 7 square plus dot dot dot. Firstly, we write the formula of sine 1 by p. Sine 1 by p is 1 by p minus 1 by p cube by factorial 3 plus 1 by p power 5 by factorial 5 minus 1 by p power 7 by factorial 7 plus dot dot. We multiply both sides by 1 by p. 1 by p sine 1 by p equal to 1 by p into 1 by p, 1 by p square. Here 1 by p to the power 4, here 1 by p to the power 6, here 1 by p to the power 8. Now we apply inverse, Laplace inverse, both sides. So right side is, we apply in right side the linear transformation property. So L inverse 1 by p square minus 1 by factorial 3, L inverse 1 by p to the power 4, 1 by factorial 5 outside, L inverse 1 by p to the power 6, minus 1 by factorial 7 outside, L inverse 1 by p to the power 8, and so on. Now find L inverse 1 by p square is t to the power 2 minus 1 by gamma function 2. Here L inverse 1 by p to the power 4, t to the power 4 minus 1 by gamma 4. Here L inverse 1 by p to the power 6, t to the power 6 minus 1 by gamma 6. Here t to the power 8 minus 1 by gamma 8. So we get t, only t, gamma 2 equal to 1 minus 1 by factorial 3, t cube, gamma 4 is factorial 3, t to the power 5, gamma 6 is factorial 5, t to the power 7, gamma 8 is factorial 7. So we get t minus t cube by factorial 3 square plus t to the power 5 by factorial 5 square minus t to the power 7 by factorial 7 square plus dot dot. Thank you for watching my video. If you are satisfied with my presentation and contents, then please click on like button and to subscribe my YouTube channel. Thank you.